Hi Dragons! So we recently completed AIM 13 where we worked on factor trees. Now I want to continue with factor trees and then I'm going to take it one step further with a little bit of enrichment to show you how to use factor trees to find the GCF. And this is a really cool shortcut and you use this in lieu of factor rainbows. So factor rainbows can get you the greatest common factor between two numbers. The prime factorization can too. We actually have 2 sheets about this, I think. We do. So this is kind of the beginner sheet. I will post a printable for you on the Google Classroom. If not, feel free to write it by hand. This is AIM 14. We're going back a little bit. We're reviewing a bunch of stuff because the DPS packet reviews a bunch of stuff. So what's special about this one, and we're going to write in a bunch of hand notes because I didn't apparently type it in. You can use prime factorization to find the GCF between two numbers. Now, first you start with a factor tree. Begin by writing the number. Choose any factor pair, but do not use 1. And then you branch out. And then you keep branching until your branches end when you hit prime numbers. You circle them. It's like circling a leaf at the end of the branch. If it's composite, that's when you keep going until it's prime. We're going to see if we can find a GCF between 720 and 175. Actually, I haven't tested this before, so this is an experiment happening. All right, 720. We're going to branch this one out. I believe 2 times 360 would get you 720. So my first branch ends here. 360 is 180 times 2. That branch ends there. 180 is 90 times 2. That branch ends there. 90 could be 30 times 3. That branch ends there. 30 could be, I'm going to fall over into my work here, 3 times 10. 10 could be 2 and 5. Okay. Let's rewrite it. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. 3 times 3. Times 3 times 5. 3 times 5. Let's see if this is true. We're just going to double check our work since it's an experiment. 2 times 2 times 2 times 2 times 3 times 3 times 5. Okay, good. All right. Now, if we were to write it in exponential form, you would take the number of 2's, make that the exponent. You would take the number of 3's, make that the exponent. And same thing for the 5. So that's an exponential form, which it asks for right here. 2 to the 4th power times 3 to the 2nd power times 5. Okay, that is the prime factorization. Let's try 175. I want to say 25 times something. 25 times 1, 2, 3, 4, 5, 6, 7. 25 times 7. 7 is prime. 25 can go down to 5 and 5. Prime, prime. Let's test it. 5 times 5 times 7. Nice. Okay, in expanded form, that would look like 5 times 5 times 7. In exponential form, that's going to look like 5 squared times 7. What do we go here? 5 squared times 7. Okay, so we got factor trees. How do you find the GCF? You list the prime factors of each number. Circle every common prime factor. That is, every prime factor that's a factor of every number in the set. So, who do they have in common? Who do they share? Do they share 2's? No. Do they share 3's? No. Do they share 5's? Yes. How many times? Once. Do they share 7's? No. So, the GCF between 720 and 175 is actually actually says it's just 5. Just 5. If it had been more than 1, you would multiply them out, which I'll show you on another example. We can test this to see if we're correct if we were to do a factor rainbow, and we could see if we got any further matches. But right now, the only prime factors that they have in common is 5, so the GCF would be 5. We're going to explore this concept more, and I'm going to double check and make sure that the GCF really is 5 between these two numbers. I'm Googling it right now. It is 5. So you'll see when we work on a different problem, the GCF won't be 5 because there'll be more than just one match in each series. So, to recap, you know how to do factor trees. We can find the greatest common factor between two numbers if we circle prime common factors between the series. We'll explore that more because that's a little more of an advanced concept, but it's super fun and it does help shortcut some work. Excellent work, Dragons. See you soon.